Welcome back to Biology Chemistry, Unit 2 on Measurement. This is Lesson 3, Video 1. So, we are going to be talking about accuracy, precision, and significant figures. So these are three really important things when we make measurements to follow. And you've probably heard of accuracy and precision before. So accuracy is the closeness of a measurement to a given value or a specific value. So if you're accurate, you're close to what you should get. So for example, suppose that a nurse is taking a patient's temperature twice and we get values of 98 and 103. The patient's true temperature is 102. The second measurement is more accurate because it's closer to what it should be. So in science, one way that we can look at accuracy is using a calculation called percent error. And that equation is given here. And there is a little typo here, so we're going to cross that out and write accepted. So with this, our experimental value, this is what you get. So when you take a measurement, that is the value. The accepted value is what you should get. So this is the true value. So based on that, just like in anything, the smaller the error, the better. So the smaller the percent error, the more accurate the measurement, and vice versa. So we can actually get positive and negative percent errors. So if we go to the next page, we can talk about that. So if we know that equation, and I'm going to put that equation back up here, right here. In order for this to be positive, we have this negative, this minus sign up here. So if what you get is bigger than what you should get, that value on top is going to be positive. When you divide it by a number, you're going to get a positive number. So positive percent error means your value that you measure is higher than it should be. Now, if the accepted value is really big and what you get is below that, then this value in the numerator of this equation is going to be negative and it's going to make the whole percent error negative. So that means that your value is lower than it should be. So let's look at our example problem here. Andre wanted to make sure that his bag of Cheetos contained the correct amount of product. The bag was supposed to have 25.0 grams of Cheetos. Andre massed the Cheetos and attained a value of 21.5 grams. What is the percent error? So with that, we are given two measurements here. We are given 25 grams and we are given 21.5 grams. One of them is what Andre got and one of them is what it should be. So the bag was supposed to have 25 grams, so that's our accepted. Andre massed it and got this value, so that is the experimental value. So now all we have to do is put it into our equation. The experimental value, 21.5, minus the accepted value, all over the accepted value, and then we take that answer and multiply it by 100. So in the calculator, I'm going to put our equation. So I'm going to do 21.5 minus 25 and hit equals. Divide that by 25, hit equals. Then multiply that by 100. you'll see that I get negative 14% error. Make sure that you're writing the percent sign and writing error after it. So a negative one means our value is lower than it should be. So go ahead and try this understanding check here. When you're done reading the problem with me, pause it, do the calculation, get your answer, unpause it, and check it. So Deidre is in chemistry class. She picks up a 400 milliliter beaker and adds water to it. When she measures the volume of water, she obtains a measurement of 410 milliliters. Go ahead and pause this. So now that you've unpaused this, we have two measurements. 400 is what it should be. She obtains a measurement, so she measured this one as the experimental. So it's experimental minus actual, all over actual, quantity times 100. And when you put this in a calculator, 410 minus 400 equals, divided by 400 equals, times 100 equals. And we get 2.5, and we write percent error. There is our answer.